Hey guys, my name's Mike Ferris,
And I'm Joe.
and we're going to be talking about our Python code and how it relates to physics.
In terms of conservation of momentum, constant linear velocity, and just basic science skills.
Yes. So we're going to go through our code first. So we made it do a visual import, so we can see the balls and how they move. The first ball is obvious. It's just right here. It's called ball. We made it a sphere. Put it at a different position than the first one for obvious reasons. This first ball will be green for all intents and purposes right there. Second ball is red, so don't get these two confused. Make sure you know which one's which because it matters a lot when you go through the rest of the code. And the square box is for no reason. It just makes it look better.
Yes, and the vector right here, the two balls start at different positions, but they will move at each other with the same velocity. So that's just our first trial. Later on, we'll explain other trials that we did that show the correlation of mass and velocity with an inelastic collision.
All right, so we also created labels. Uh, they'll be right above the ball, and there's one right below the ball. This will show the velocity before the collision and the velocity after the collision. This is important as it is it's the key part of the experiment to show how momentum is conserved and how velocity changes.
With this trial, we have the velocity at the same, but with mass, we have two different numbers. So mass 1 is 0.5 and mass 2 is 2. And so we should see with this inelastic collision that the mass with the greater, or the ball with the greater mass will overtake the ball with the lower mass, and they will stick together and just keep moving in a constant linear velocity towards, well, in this case, the left. This rate right here, it just says how fast the Python program spews out frames every second.
This first part right here, ball dot position, this changes it pretty much moves the ball around. The ball's position where it is currently is plus the velocity times the derived time. And so as the time moves, the ball moves as it does in real life if we were to roll a ball across the carpet. And the ball labeled next, just it follows the ball's position right here, just follows its position. Next is ball 2 position. Is the same thing as the ball position before it. It just moves the ball 2 around. Same thing with ball label. The label just follows the ball. So next we have the ball position on the x-axis and the ball 2 position on the x-axis subtracted from each other. So that way when they collide, the computer will know when to initiate the equation that we set up. Now here's where the real conservation momentum kicks in, is this equation right down here. This changes the ball's velocity to the equation that we learned in class, except we switched it around so velocity would be equal to just a bunch of variables that we could plug in to the rest of the program. So we made it so the mass of ball 1 times the ball 1's velocity plus the mass of 2 times ball 2's velocity is all divided by the mass of both, which creates a new velocity for both the balls after the collision. Ball 2 velocity after the fact, right down here, and the ball velocity, we tell them to be equal to each other, so after the collision they will both be at the same speed.
Alright, so what you should see when we run this Python program is ball 2, the red ball, should overtake ball 1, the green ball, because the red ball has a mass that's greater than the green. And so we will run it. And as you can
Boom.
see, the red one overtakes the green one, but they stick together because it's still an inelastic equation.
As we change it, we can change for our first trials over here in the spreadsheet. We changed just the masses of the balls at the very beginning. This shows how the velocity after the collision is affected. With obviously a higher mass hitting a lower mass, the velocity after the collision is greater. And that's seen with, especially with the 0.1 and the 5. We're actually just going to show you that one really quick. You just have to change the variable right in there. Boom. And now it equaled the velocity after the collision in our spreadsheet.
We know that mass and velocity contribute to momentum. So if we kept mass constant and then changed the initial velocity of both the red ball and the green ball, we should see results similar to the mass, where when it's changed, a ball will overtake another. So in this first trial, we will change the initial velocity of ball 1 to 1, and we will change the initial velocity to -5 meters per second.
We run it in what we assume are the units, as there is no actual unit in the Python program. We run it in obvious assumed units for what real life would look like. So here's that module.
And because ball 2 had an initial velocity of -5, its speed will overtake ball 1, whose initial velocity was just 1 meters per second.
Here's it a little slower.